Welcome. This is task 2. Here I'm analyzing the unemployment dataset. First of all, I'm importing the essential library that is required. I'm using pandas, numpy to perform mathematical operations, plotly, cborn, and matplotlib I'm using as a data visualization library. Since the data is divided into two parts, first, I am reading the first data set, which is employment in India.csv file. Then next, I am using the second data set, which is unemployment rate up to 1122.cs. Then I am looking at the data using the df.head command and df.to head command. So this is how the data look like of DF1 and DF2, which is the unemployment in India and unemployment rate up to 11/20/20. Then next I'm checking how big is the data using the df.shape command. So data 1 consists of 768 rows with 7 columns, whereas data frame 2 consists of 267 rows and 9 columns. Then I'm further checking the null values in a particular column on two different data sets. So in data 1, region consists of 28 null values, date again consists of 28 null values, frequency, unemployment, estimated employed, and labor participation rate. Even area consists of null values. In data 2, no such null values are present. Then I'm dealing with the null values itself in the data frame 1. Then I am combining the data set of df1 and df2. Since columns are the same, only the longitude and latitude is been added and region as well is added. So I'm just concatenating the data, and this is how the data looks after concatenation. This is how the newly formed data is looking. After running df.info command, it gives me the data types of the particular column. So region, date and frequency are object column. Even area and region column is object. Rest, all of them are float data type. This is how I am using describe function, including all the columns in the dataset to see how does the data looks like mathematically. So include all means it will also consider the data which is categorical or of data type of the object. So region, it counts 1007, 28 are unique, and most frequent region is Andhra Pradesh with a frequency of 38. Similarly, it goes for all. Further going on to the numerical column, the count remains same. The mean standard deviation minimum value 25th percentile, 50th percentile, 75th percentile, and the maximum value of a particular column has been given. Then I'm again going for the null value check. Here the area consists of 267 and region 1, longitude, latitude all consist of 714 null values. So to deal with null values, since df2 was the data set consist of longitude and latitude, I found out that the region has the same longitude and the latitude, and also the region are same. So in order to remove these null values, what I have done is I've made an algorithm to remove that null values. Is that I've created a dictionary. I'm going all values of data frame and selecting the column number where the value is not null. If the value is not null, then I'll update the dictionary. Then I've created a list. I've run a loop through different values, check through the columns. If it is equal to none, then I will check if the region is present in the dictionary or not, and replace that null values with that particular values. Like over here, Andhra Pradesh has no region, no longitude, latitude in the first data frame. So I have taken the region, longitude and latitude from data frame 2. Else I'm doing it as missing data. Miss can be anything, and else I'll directly append the value as it was and return the list. So whenever I'm calling rem null function, I will pass the column number, which is sixth in the sense area column, and missing is replaced by urban. Similarly, it goes for region 1, 7 and north. Since Chandigarh is the only city without location, I'm providing the details with north, urban, and I've also provided with the longitude and the latitude of that region. Then again, I'm doing df.null is null condition to check whether the dataset contains any null value or not. Then I'm running a basic information check on how does the data look like, and then I'm going for checking the duplicate values present in the dataset. Further, on exploring the data, I'm also plotting the correlation in the data. Since there are only 3 columns which are numerical, so we can see that the column has the negative correlation. No duplicate values are present in the dataset, and pre-processing of columns such as data and estimated employee is required. So going on to the second step, which is the pre-processing of the data. Since date should be in date time format, I've used pandas library to convert the date column into date time, and since the estimated employed rate has a float value, and after point we are getting a 0, so in order to reduce the space, I've converted the data type into integer. Then I've extracted the day, month and year and day name from the date column. Then I've deleted the columns which are not of use, and I've reindexed the column. After reindexing, there are unnecessary spaces between the columns, so I've removed the data and I've changed the name to this. Going on to the data visualization and analysis, first of all, I've done the univariate analysis of a column. In this, I've used plotly.express library to plot the bar chart of the states of each states with total number of counts, meaning that how much times a particular state have appeared on to the data set. So here we can easily see that Andhra Pradesh as total value of 38, meaning that 38 times Andhra Pradesh have appeared onto the data. In a similar fashion, Kerala, West Bengal, and so on. And least appeared is Chandigarh, which is 12. Going on to the bivariate analysis, here I have plotted a histogram using the Seaborn library between the estimated unemployment rate to a particular region. We can see that South region is classified as blue, Northeast region is classified as yellow, East region is classified into green, and red is classified into west, and purple is classified into north. Further, I am performing a group by on a region and only considering estimated employed, estimated unemployment rate, estimated labor participation rate, mean value. So this is what I've got on group by on a particular region. Then further plotting these divisional unemployment estimated unemployment rate according to the values, which is sorted and onto a bar. So North has the highest estimated unemployment rate and Western region have the lowest estimated unemployment rate. So through this estimated employed and divisional estimated unemployment rate, we can calculate the estimated unemployed, means the total number of people who are unemployed. Then again I have plotted it to the estimated unemployment rate with sort underscore values and descending. So this is the graph what it looks like. Then these are for few of the conclusions that have been made using the visualization done above. States in the northern highest rate of unemployment rates in the year 2019 and 2020, whereas western states of India have lowest rates of unemployment rates in 2019 and 2020. Southern region have the most average number of employment. On contrary, western region have the lowest average number of employment. Labor's participation rate are the most in the northeast region and lowest in the northern region. Northeastern states have the highest estimated unemployed people count, whereas the eastern region have the lowest estimated employed. This is what multi-column analysis looks like. So I have used the Plotly library to plot a bar graph on a particular region or different region, and the estimated unemployment rate. I have set an animation frame on a particular month and the color as states. So this is the unemployment rate across the region, and when I run this shows that monthly analysis on a particular states on how does the data changes or based on the region every month. This is the pair plot of a particular area, two different numerical columns. This is the area wise analysis. So what here I am doing is I'm taking the data frame, I'm grouping it by area, and I'm only considering these columns, which is the estimated employed, estimated unemployed rate, and estimated labor participation rate dot mean. Then here we can also calculate the estimated unemployed number of people, since we have the area estimated employed, means people employed in a particular area, and we can multiply it into unemployment rate divided by 100. So we can get the number of or estimated unemployed people in numbers. Then I am drawing a pie chart. So year wise unemployment is that rural areas and urban areas have similar unemployment rates. Then on going by the daily analysis, I've grouped by the day name, which is then again I've calculated the estimated unemployed people. I've shown that on Sunday and Thursdays people are hiring less. So unemployment people are more on Sundays and Thursdays. Going further on to the monthly analysis. Monthly analysis again I've grouped by the data on month. I've taken this many columns, mean of that columns, and then I've calculated the estimated unemployed people and found out in the month of April, May, and March there is an more unemployed people. Further, going on to the yearly analysis, I am grouping the data into year and taking the mean of estimated employed, estimated unemployment rate, estimated labor participation rate. Again, going with the estimated unemployed formulation that I've done above. Or in the year of 2019, there is a 33.25% of people being unemployed. Whereas in the year of 2020, we can see that 66% of people are unemployed. So in the year 2020, the unemployment rate has increased twice the numbers. On map analysis, this is the scattered geoplot of the Indian map. Unemployment in states of Bharat. In the year 2019, the unemployment rate can be easily seen by just hovering over to a particular and see that it gives us up the basic details of the region, area, year, and estimated unemployment rate and longitude and the latitude of a particular region. So I have classified it into the region area wise or to the region wise. So all the orange plots show me the northern region, green plots show me the eastern region, violet color shows me the region of western region, and purple color to south, and red color for the northeast region. After playing, I've got a sudden increase in the data. So these are few of the conclusion that can be made, that from pair plot, day and year are not evenly distributed. Both in case of urban and rural, an estimated employed and employment rate are both right skewed. Labor participation has evenly distributed graph, whereas in area-wise analysis, rural and urban are both evenly distributed. Both share equal number of percentage share. In daily analysis, Sunday has the highest people unemployment. In monthly analysis, April has the highest unemployed people. And in the year-wise analysis, the unemployed people have risen from 33% to 66%. Thank you.